All right, so before we move on to example 2, let's define some vocabulary. Since the title of this section is Identities, Expressions, and Equations, we should probably define what those terms mean. So, an expression is contains an unknown value, but no equal sign. Okay, so an expression would be something like 2x squared. All right, it's just 2x squared. 5x squared minus 7. Okay, there's no equal sign. That's the key thing here, is that there is no equal sign. All right. An equation has an equal sign, which makes sense because it has the, you know, it says equation, so it has an equal sign. So it's just any mathematical statement that contains an equal sign is an equation. Now, an identity is a special kind of equation. Okay. Now, with an equation, usually, if you look at one of these equations, we're looking to solve for x, right? So these equations, like that are shown here in this box, those are true for only certain values of x. They're not true for all values of x, right? There are just certain values of x that we can find that make this equation true. But an identity is something that's true for all values of x and y. In this case, I get some y values in there too. All values of x and y satisfy these equations. So things like x plus y is equal to y plus x. That's just the commutative property of addition, right? And that's true no matter what x and y are. Same way here, this is the distributive property. And so no matter what x and y are, if I have 2 times the quantity x plus y, that's equal to 2x plus 2y. Okay, those are identities. Right? They're true for all values of x and y. All right, so let's take a look at using these things we have up here I called identities. Right? They all have equal signs in them, right? And they're true for all values of theta and in some cases phi. All right, so these are identities, and we're going to start using those identities. Let's use identities first of all to simplify expressions. All right, so we have in this example we have an expression. There's no equal sign at all. We just want to simplify this thing. All right, now this is kind of a complicated one. It looks messy, especially with a cosine and sine. So one trick you can use to make it look a little simpler is just to do a little substitution. I'm just going to let r equal cosine of t. That way, when I write it, I can just write r instead of cosine of t. And I'm going to let s equal the sine of t. Okay. So now if I rewrite that, then basically what I have is 2r plus 3s times the quantity 3r plus 2s minus 13sr. Okay, it's a little bit simpler. All right, now I want to simplify it. So I'm going to FOIL this out. I'm going to multiply these two binomials. So I'm going to take, multiply the first times the first, which gives me 6r squared. First, outer would be 2r times 2s, which gives me 4 sr. Now I could write it 4rs or 4sr. It's the same thing because multiplication is commutative. It can be multiplication. You can multiply things in any order. Inner, okay, so I'm going to get plus 9sr. And then the last. So I'm going to get 6s squared. And then I have this minus 13sr. All right. So we've FOILed it out. Now you might notice that 4sr plus 9sr is 13sr. And then I'm subtracting 13sr. So what do you know? That goes away. All right. If I take 13sr minus 13sr, that's gone. So now I just have 6r squared plus 6s squared. And I can factor a 6 out. That's the same as 6r squared plus s squared. All right, that looks pretty simple. Now let's go back and resubstitute for r and s. So what is this saying? This is saying that So r was our cosine. So this is cosine squared of t plus sine squared of t, because our s was sine. Now we know using the Pythagorean identity, right? The Pythagorean identity says that the sine squared of t plus the cosine squared of t is equal to 1. Okay. Now this is cosine squared plus sine squared, which is the same thing because addition is commutative, right? I can add things in any order. And so this expression in parentheses is just 1. So this all boils down to just 6. That is the value of this expression. It's an equivalent value to this expression. And just use a little algebra and the Pythagorean identity to convert that complicated expression down to just 6. All right, so I will meet you in the next video.